Welcome to ePadashala PG Computer Science courses. Today in Web Technology subject we are going to see the module number 39, which is JMS. JMS stands for Java Messaging Service. So today we are going to learn about Java Messaging Service and its fundamentals. Also we are going to learn about the advantages of JMS and applications of JMS. We are going to learn about the various components, programming models of JMS also, messaging models as well as programming models of JMS also. First, let us see what is messaging. Let us go through the definition of messaging first. Messaging means it is a method of communication between software components, or it is a method of communication between the applications. Messaging system of course is followed or is considered as a peer-to-peer facility. The messaging system differs from tightly coupled technologies. We would have studied earlier the tightly coupled technologies such as RMI, which is remote method invocation, but the messaging system is completely different from it, and this also gets differed from email system also. So, but messaging enables distributed communication, but the distributed communication is purely loosely coupled and not tightly coupled. Okay. Again, messaging system, we have seen that already it is a peer-to-peer facility. It allows any number of computer applications to communicate with each other. This application can send messages to or receive messages from any application. You can see in the below figure that one application can send any number of messages, at the same time it can receive also receive messages from any other applications. So each client, it connects to a messaging interface, and through that interface it gets the facilities for creating, sending, receiving and reading messages. So this interface is responsible for sending, receiving and reading messages. It acts as a communication medium. Now let us see about the client, messaging client. Messaging client means again it is a system. It handles the communication between the application interface of one system to application interface of another system, or it acts as a communication between the application interface and the physical network which connects between these two systems. So a client can either be an open source or it can be a commercial product. You can choose any of the client. The client deals with the issues such as how to send a message over an unreliable network also. You can see that we are seeing that one client is getting communicated with other client, but it tries to communicate through that interface. This is the interface where the messaging operations takes place. Now let us see about the introduction of Java Messaging Service. This is introduced by the Sun Corporation as J2EE technology in 1999. So the earlier things are called as web services, Corba and Java RMI. So all of these things by default belongs to synchronous communication. Let us see what is a synchronous communication. If it is a synchronous approach, the client makes a call and waits for a response. Until without the response from the client, it cannot send a message. This system is called as tightly coupled system. But the JMS promotes loosely coupled system. JMS is nothing but a Java API. This API allows the applications to create message, send, receive and read messages. Again, this API defines a common set of interfaces and associated semantics. This allows the program written in Java programming language to communicate with other messaging implementations. So this JMS API purely follow the Java programming language constructs, and using these constructs it tries to communicate with other messaging implementations. Now I told you already that JMS API enables not only a loosely coupled communication, the main thing is it is loosely coupled, not only that loosely coupled, it also provides asynchronous communication. Asynchronous in the sense the JMS provider can deliver messages to a client as they arrive, and the client does not have to request messages in order to receive them. Once the message has been delivered, it is automatically consumed by the client on the other end. And the second kind of communication is it is reliable. JMS API can ensure that a message is delivered once and only once, no repetition or no duplication of messages. The different levels of reliability are also available for the applications, for the applications which miss messages or which receives duplicate messages. So, here it is delivered once and only once. Now, let us go through the specifications used for JMS, which is licensed by the lot of vendors. BEA is one spec which is called as, the technology is called as WebLogic, where IBM is a corporation which releases WebSphere, Sun releases Sun 1 message queue, TIBCO released TIBCO Enterprise for JMS, whereas the product of Oracle is called as OJMS, Oracle Java Messaging Service, and the product of Fiorano is called as Fiorano MQ. Apart from these proprietary licenses, some open source implementations are also available. Among these things, this OpenJMS is an open source based JMS product. Now, let us look through the JMS real-time example in real time where JMS is required. Let us assume about a company which consists of many departments like inventories, factories, parts production, a lot of things. The inventory component can send a message to the factory component. When the inventory level for a product goes beyond the certain level, that is, if it goes beyond the minimum level, the inventory can automatically send a message to the factory component so that the factory can make more cars. The factory component can send a message automatically to the parts component so that the factory can assemble the parts it needs. Whenever it requires the parts, it sends a message to the parts component. Now, the parts component in turn can send message to their own inventory, that is, which is required under parts, their own inventory, and order the components to update the inventories then and there and order new parts from suppliers also. Now, both the factory component and parts component can send messages to the accounting department or accounting component to update their budgets. So, the business publishes updated catalog items to its sales force as well as in the website. Now, you can see that the messages has been promoted from one particular component to another particular component automatically, so that through this automated messaging service, nothing would be stopped, everything goes in a pace. Okay, now let us look through the advantages of JMS. JMS is asynchronous by default, I told you already. To receive a message, the client is not supposed to send the request. The message would automatically arrive to the client as they become available. There is no need that it has to send the request. So, that is why we call it as asynchronous. Then reliability. JMS provide the facility of assurance that the message will be delivered once and only once. It avoids duplicate messages. Now, let us have another look on popular JMS providers. IBM is one JMS provider which gives WebSphere MQ. Oracle also gives WebLogic messaging. Apache gives Active MQ. Rabbit Technologies give Rabbit MQ. JBoss, Hornet, Progress Software provides Sonic MQ. TIBCO gives TIBCO EMS, and Oracle Corporation, already we have seen OJMS. Apart from that, OpenMQ also has been provided by them. Now, let us look through the JMS application. Every JMS application is composed of the following parts. First, JMS clients. These clients are nothing but Java programs which are responsible for sending and receiving messages. Then, non-JMS clients. These clients use a message system's native client API instead of JMS. That is, there is a possibility that the client may be either JMS based client or non-JMS based client. If it is a JMS based client means then it is Java language programs. Non-JMS means it uses native client API. Now, messages, this is what going to get communicated between these publishers and subscribers. So, each application defines a set of messages and this is used to communicate the information between the clients. Now, provider is there and consumer is there. First, let us look out the JMS provider. Provider is again a messaging system. It implements JMS API in addition to other administrative and control functionality. Apart from the JMS provider, we have some administered objects also. Administered objects means they are pre-configured JMS objects. These are created by the administrator for the use of clients. Now, you can look through all of the components in which the JMS application consists of. So, I told you already that every JMS system or every JMS application should consist of a JMS client. JMS client can be of two types, either a message sender can be a client or a message receiver can be a client. Apart from that, JMS provider will be there, providers will be there. The provider is responsible for sending these messages. Then JMS administered objects are there. Under administered objects, two things are available. Connection factory is there and the destination is there. Destination is the place where the messages get stored. And finally, the JMS message. Message is actually the component where the information we want to communicate gets stored. Now, let us have a short look about the administered objects. I told you already that administered object consists of two things, connection factory and destination. Now, you can go through this. Connection factory means it is an object a client uses to create a connection with the provider. That is, in order to establish a connection with the JMS provider, this object has been used. And destination, already I told you that the client uses this destination to send the messages, that is to specify where these messages should be destined, that is where this messages should get stored, so that when the receiver wants to receive it, it can receive from the source of messages. We will look through in the upcoming slides that each and every component. Now, before going through the components of JMS one by one, let me give you an overview of JMS communication models. There are two types of communication models followed in JMS, synchronous communication and asynchronous communication. If I go through synchronous communication, both the communication parties need to be active. The sender receives confirmation from the receiver. Until the confirmation gets, calls are blocked in synchronous communication. That is, no more further communication takes place until it receives a reply from the provider or consumer. This is useful for only the scenarios where global authorizations are required. For example, credit card authorization, you can see that until the receiver gives the approval, the sending system cannot proceed further. This is called a synchronous communication. Let us look through the asynchronous communications. Here, there is no need that both the parties should be working in the same pace. Both the parties do not need to be active during the same time or during the communication time. Here, confirmations are not required. Here, calls are not blocked since the receiver has not replied. But whereas in the synchronous communication, the calls would be blocked if the receiver has not replied. This is more useful when massive communication processing is required. And this allows the efficient usage of hardware resources also. Now, let us look through the messaging models of JMS. First, JMS API supports two different types of models. The first one is called point-to-point messaging model, which we call it as PTP model. In point-to-point messaging model, a producer creates and sends a message which will be received only by a single consumer. So, the producer is also going to be one person and the consumer is also going to be one person. In point-to-point model, the message destination is called as a queue. Because if the producer produces and puts it in the queue and the consumer consumes from the queue. While we take the characteristics of PTP, each message is consumed by only one consumer. A sender and a receiver of a message does not have timing dependencies. That is, the receiver can fetch the message during the same time it has been received, or during the running time when the client has sent the message, or after the client has sent the message also. That is, it does not depend on a particular time. There is no timing dependency. Any time it wants to receive, it can receive it irrespective of the time it has been sent by the client. Now, the receiver acknowledges the successful processing of the message. This is what the messaging model for a P2P communication, that is point-to-point model. You can see that two applications are there. One application can be considered as producer and the other application can be considered as the consumer. You can see in the middle that mom, this is nothing but that is JMS provider. The destination is composed within the JMS provider. The destination is visualized as a queue. The producer, whoever produces the message, sends the message to the queue. From the queue, the application on the other side, that is the message consumer, tries to consume the message. Once it consumes the message, it sends the acknowledgement back to the destination. So, this is what we are seeing, that each message is going to have only one consumer. Now let us look through the second model, which is called as publish subscribe model. So pub sub model, this can also be called as PUB SUB model. In publish subscribe model, any number of clients can subscribe to a message destination. That is, many number of clients can say that I want to consume this particular message from the destination. And when a node sends, the sending is called as publishing here, and when a node publishes a message to the destination, the message is received by all the clients who have subscribed to that destination. So you can understand that in the destination, many clients can register that we require this particular message. Once this is registered, once the sender sends the message to the destination, immediately all the clients who have subscribed for it would consume the message, or they would receive the message. So in this model, the producer is called as the publisher and the consumers are called as subscribers. And the message destination, in the previous model we use the message destination as queue. Here the message destination is called as topic. Now the characteristics of publish subscribe model. Here each message can have multiple consumers, we have seen already. The publishers and subscribers have a timing dependency. In the earlier model, since only one consumer is going to consume it, there is no timing dependency, but here we have a timing dependency. Timing dependency in the sense a client that subscribes to a topic can consume the messages after the client has created only, or the message is going to be active, or it is continued to be going to be active for a particular time. Within that time the client has to consume the messages, whatever it want to cater. It will cater the message to the destination, but the receivers has to receive it within a particular time dependency. Now you can go through that. This is publish subscribe model. Again the message destination, in the message destination we are seeing a topic rather than a queue. So topic is going to be the representation in the destination, and the message provider is responsible for having this destination. One application is going to publish the message. Publish the message is nothing but sends the message to the topic, but the message on the other side is consumed by many people. You can see that application 2, application 3 and application 4, many message consumers are available. All of these message consumers would first subscribe to the destination saying that I require this message. Once the message is available in the destination, the message would be delivered to all of these consumers. So that is why we say that each message is consumed by 0 or many consumers. These are the two messaging models of JMS. So now we can have a comparison between point-to-point messaging model and publish subscribe messaging model. Here each message is delivered to one and only one JMS receiver, whereas here the message is delivered to multiple consumers. P2P model has no timing dependency, whereas publish subscribe model has some timing dependency. Here the receiver sends acknowledgement to the JMS sender once it receives messages. In the subscribe model, acknowledgement is not required. So this is what our two different types of messaging models with respect to JMS. Now let us look through the JMS programming model. I told you already that every JMS application should consist of the following building blocks. That is, it should consist of administered objects, where administered objects is split up into two things: connection factories and destination. Again, connections are required. Under the connection sessions are there: message producers, message consumers and message listeners. Now let us go through each one of them one by one. First, let us look through the programming model. As I told you already, connection factory belongs to administered objects. Connection factory is the initial thing. Connection factory creates connection, where connection in turn creates session. Session in turn creates message producer. Session in turn creates message consumer also. So whatever messages which has been given by the message producer is sent to a destination. Now the destination may contain a queue or it may contain a topic. It can follow any one of these representations. Again, the message consumer receives all of these messages from the destination where the producer has sent the messages. So these are all the components of a JMS programming model. Now let us look out this model one by one. Now let us start with connection factory. If you go through the connection factory, a connection factory is an object, that is a client uses it to create a connection to a provider. You can see that provider here we can say either it may be a producer or it may be a consumer. In order to get a connection or in order to ping a connection with the provider, the connection factory creates a connection. So, the connection factory encapsulates a set of connection configuration parameters also. So, the client uses it to create a connection to JMS providers. You can see that the connection factories comes in two forms. Implementing either we can follow a queue connection factory or we can follow a topic connection factory interfaces. Now, let us look through the code for it. These are all the classes which are available with the JMS. The parent class is javax.jms.connection factory. This is an interface. This is a parent interface. This interface has been extended by two interfaces. If we are going to follow the queue model, then we can make use of this queue connection factory interface, or if we are going to use the topic model, then we can follow topic connection factory interface. So, we usually before pinging up with a connection factory, we usually perform a JNDI API lookup of the connection factory. So, in the API lookup, it looks up the context and finds out the connection factory. So, this establishing a connection with this queue connection factory and topic connection factory has been given in the following code snippet. Now, you can go through it. An object or an instance for the context class has been created. The context gives you the new initial context. What is going to be the initial context that has been obtained in the context object? Using that context object, that is what is going to be the current context prevailing, that is native API prevailing. Based on that, it looks up for connection factory. Once it gets or once it searches the connection factory, the handle to the connection factory has been transferred to the variable connection factory. You can see that where the connection factory variable belongs to the data type of connection factory. Suppose instead of this particular interface, we are very particular that we are going to use queue connection factory, means then an instance can be created for the queue connection factory interface. If we are going to make use of topic connection factory, then an instance for topic connection factory can be used. You can go through the code snippet that either we can make use of 2 or 3 based on the representation of queue or topic. Only through this connection factory or only through the handle of the connection factory we can create a connection. So, that is what we are going to see in the next slide. So, connection. Again, connection means it encapsulates a virtual connection with a JMS provider. This encapsulates the TCP/IP link with the JMS provider. This connection authenticates the client and it specifies a unique client identifier. Like connection factories, connections also comes in two forms. Here you can see that only based on the connection factory we are creating a connection to the JMS provider. So, here we are going to see about the connection. So, connections also comes in two form, either the queue connection or topic connection interface. Now, we can go through the code for it. Again, you can see that the interface is called as javax.jms.connection. This has been extended by two interfaces, queue connection as well as topic connection. Again, based on the usage of queue or topic, we can choose any one of the connections here. Again, the connection using the handle which has been created as connection factory in the previous slide. Based on the usage of this connection factory handle, we can create a connection here. Then again, the connection can be created as either queue connection or topic connection. Again, this queue connection or topic connection has to be created only from the queue connection factory handle or topic connection factory handle that you can see in the second and third lines. From the queue connection factory handle, create queue connection of, create topic connection of. Okay, this is just establishing a connection to the JMS provider where the connection has been derived from the connection factory. Now, again, after creating a connection, we can create one or more sessions or we can create a number of message producers also. But once the application has been completed, we have to close these corresponding connections, whatever we have created it. So, for closing the connection, we can use connection.closeoff. If it is a queue connection, then we can make use of queue connection.close. If it is a topic connection, we can make topic connection.close. This is with respect to the connection. Next to the connection, is going to be the session here. Here you can see that connection factory creates connection, where connection in turn creates the session. Session in turn creates either message producer or message consumer. Finally, all of these messages goes to the destination. So here first we are going to see what is a destination, and then let us come back to the session. So let us see what is a destination. Destination, we have seen that it is a JMS administered object. This encapsulates a provider specific address. It gives a specific address for storing of messages as well as for retrieving of messages. The destination is an object a client uses to specify that this is the target where the message produced has to be stored, and again this is the source if you want to consume some messages. Destination is purely meant as a target for storage when the message has been produced, or it has been mentioned as the target for consuming it has been mentioned as a source for consuming the messages. So destination, like session, it can also comes in two forms. Either you can implement queue based interface or topic based interface. Now let us come back to the session. I already told you that connection factory creates a connection, where connection in turn creates a session. Only through the session we can communicate either with the provider or with the consumer, or that is the message providers. Now session means it is a lightweight JMS object. This acts on a single threaded context, and this is responsible for producing as well as consuming the messages. Now the session is responsible for creating message producers, message consumers, messages and message destination. Now sessions, again like a connections, again like a connection factory, session can also comes in two forms. Either it may implement the queue session interface or it may implement the topic session interface. Okay. Now let us look through the session hierarchy. Again the session hierarchy is an interface, JMS.session interface. It is extended by two things, queue session interface and topic session interface. Based on our usage, we can use any one of these two interfaces. Again you can see three statements to create a session. That is, first we used a connection factory. Using a connection factory we have created the connection in the earlier statements. This is what used to create a connection or to establish a connection. Once the connection has been established, you can see that the variables connection is available, queue connection is available, topic connection is available. Using these three connection variables, now we are going to establish a session. So you can see that queue connection dot create queue connection off, topic connection dot create topic session off, create queue session off. In the first one, create session off false comma session dot dupes OK acknowledgement. It says that the sending of acknowledgement while receiving the messages or sending of acknowledgement is very lazy. That is why we say that dupes OK acknowledge. Whereas in the second type we give session dot auto acknowledge. Once a message has been received, it will send an acknowledgement automatically. That is what the second one. Now the third one also we are saying that the acknowledgement has to be sent. So this is what creating session from a connection. Okay. Now we have seen the destination already. I told you already that destination can be implemented either using the queue interface or the topic interface. Again this has been given here. Destination has been extended into queue destination or topic destination. Here you can see an example for the destination. Again context.lookup, because this example makes use of the queue. That is why the data type has been casted into queue, context.lookup of queue, where the return type is casted into queue. From that queue again we are making context.lookup of queue my queue. That is, a queue has been created in the destination. Now we have seen connection factory, connection, session and destination. I told you already that session consists of, or session creates message producers, message consumers, messages and message destination. Message destination we have seen in the subsequent slides that either the destination can be queue or topic. Instead of seeing this producers and consumers, now let us look through how the messages would be. Now this is what the component of messages. JMS application produces and consumes messages. The message interface, there are 5 different types of message which are followed in JMS: bytes message, text message, object message, and object message, stream message, and map message. Summary. So, in this session, we have learnt about the basics of JMS, we have learnt about the advantages and applications of JMS, we have learnt about the various components of JMS, we studied 2 messaging models, that is point-to-point model and publish-subscribe models of JMS. We have explored what the JMS messaging model, that is the programming model of JMS looks like, what are the components the JMS application consists of, and we have learnt about what is a message which is created and sent and received by the JMS. Thank you.